Hello everyone, my name is Jun Liang and I'm a developer. Today we're gonna talk about some exciting stuff, 3D. So we're gonna talk about ReservoirGrid. ReservoirGrid is an object that visualizes petroleum reservoirs in 3D. It's based on Toolkit's 3D module and it extends 3JS. It uses WebGL 1.0 and GPU rendering. That means if you have a better GPU, you can get a better performance. So our module reads local data sets and it can render up to 1 million cells with entry-level GPU. For example, my GPU is NVIDIA 1050, so the performance is good. The reason why I want to talk about ReservoirGrid is we have a major update in this release. So you can see some differences both in visual and performance. It can render more cells but use less memory. First, data construction. So data is the most important part in 3D because we need to load the data to GPU, and so GPU can do some calculations and rendering. So on the left-hand side, you can see a cell. It has 8 vertices. That means we need to provide 8 positions for each cell. We have XA to XH and so on for Y and Z. And for each cell, we have an index. It's called IJK index. That means, for example, this one is 000 and next cell will be 001. And we also need to provide value for color. I know in some applications, you might have different format for reservoir, but that's the format we want when loading to GPU. So you might have binary format or other stuff, but maybe it's better to convert to this kind of format so the GPU can read the data. Once we have the data, we can instantiate the object. So if you look at the sample code, it's very straightforward. You have the data and you set some parameters. In our case, skeleton means outline, so we can change the outline color to dark gray and we can set the width. Also, you can make some change to color provider. For example, if a cell has value 0, in this case, it will appear green in the scene. So we keep this very simple because when it involves 3D, it can get really complicated, and we don't want our developers to work with some complicated stuff. For example, if you want to do a simple rotation in 3D, that actually involves matrix calculations and other low-level API stuff. Filtering is a common tool in Reservoir. So you will be able to view a subgrid or interested color range. This picture shows a sample sliders. For example, if you drag this I value and in the scene, it will cut off the I axis. So you can see some interesting part. Of course, you can have your own UI. For example, many of you use Angular, and Angular has its own UI library, but the API is the most important. So once you drag some slider, and it will trigger the callback function, which send the value to our reservoir, and it can make some change in GPU side. Our update is good, but it has some limitations. For example, since it loads data from local, so that means all data need to fit the memory. IJK index system is now agile in 3D space. For example, IJK can help you locate a specific cell, but what if you want to select a subgrid of the cell? So you might have to combine a bunch of IJK values so you can keep track of the cells. So that's not perfect. Level of detail is not supported. Just in case some of you haven't heard about level of details, that means if you move your camera closer to the scene, it will show more cells, and it will has a higher resolution. If you move your camera away from the grid, it will see less cells and a lower resolution. Okay, so I want to introduce Octree in ReservoirGrid. So I want to mention that this is not something you want to implement in your user applications, but it's so common in 3D. So I think if you're interested in a video game or something, you must know about this. It makes interacting with 3D much easier. So in our case, we introduced this data structure for four reasons. The first one is level of details. So in this picture, you can see this one, let's say it's level 0. And for this one, it becomes level 1. So they have the same volume, but the second one has more cells. Spatial indexing. So for example, maybe this small cell is 000, but what if we want to select a subgrid of this grid? So we can just locate this subgrid by going to level 1, subgrid 1, just for example. And also it provides depth first traversal, so we can do fast searching. We will talk about the last of them in next slide. So in 3D, Foursome column is a very common technique for performance optimization. In this case, we have a camera here, and that's the stuff you will see on your monitor. If we choose to render all the grid, the whole grid, it's a waste of resources. So and it might decrease the performance. So we don't want to do that. We just need to do a tree traversal, and we can locate those cells. Maybe you guys all hear about recasting. So if you're interested, so we send a ray from the camera, and if the ray intersects with the subgrid, that means this subgrid is inside of the camera view. So we choose to show them in the screen. So if it doesn't intercept with the subgrid, we just disable it. Okay, so we have talked about the optimization we can do in ReservoirGrid. And now it's time to integrate those optimizations to ReservoirGrid. We have a new module, which is called GigaGrid. The name of GigaGrid means you can render several gigabyte data in one object. It has following additional features. The first one is it can fetch dataset from the server. So now not all data is located in your memory. In our sample demo, we have around 16 gigabyte data. So you don't have to have like a 16 gigabyte RAM PC to run the application. And we have a event system. We will explain this later. I will show you how you can get real-time interaction with this object. For the result, it can render up to hundreds of millions of cells on a mid-end computers. So it's a very big improvement from regular ReservoirGrid. Data source, just like how I introduced the ReservoirGrid, the data is the most important part. And this time we put all the data on server. So that means we need to have a data source so you can fetch data, you can communicate with the server. So we can build multi-level GigaGrid binary data from, I think it's called Grid Eclipse. Maybe some of you are familiar with this. In our case, we use HTTP request. So we have a example UI. That's the parameters you need for communicating with the server. And also, if you want to build your own backend server or implement your own data source, you can do that by inheriting from our AbstractDataSource. This is a sample of the implementation. So you will have an abstract method query. That means anything you want to query from server, you go from here. And we also provide 4 kinds of query mode. The first one is called no query. So no means tree node. So if you still remember the Octree we talked about, so that means we query a single node information, like a level and index, for example. And the second one is cell query. So you can query positions from the server. The third one is called property query. Property means color property, so you can get color values from the server. And the last one is reservoir query. That's actually the most basic one. It contains information of overall GigaGrid, like how many levels you have in this grid, how large is the grid, and how many cells it contains. So we already have the data from server. Next thing is instantiation. It's a little bit different from ReservoirGrid because this time we need to get data from server. So it's a synchronous process. That means you need to get the data before you instantiate the object. But if you look at the parameters, they're almost the same. So for IJK and property filters, it's not built in because we want to fetch the exact data from the server. So we don't deal with the data locally. Another step is called cache limit. We will still use local memory, but it's much less. We use it as a cache. So we put some recently used cache recently use data in cache, so we can fast access the data. We don't have.
What are units for cache limit? Like what unit?
Oh, that means if you have a PC with a high RAM, so you don't have to set the limit. It means the default limit is very high, so you don't have to change it. That's good. But if you have a low end
no, I'm asking about, is it like amount of memory? Like
yeah.
In terms of memory, yes.
Yeah.
Not in percentage of the size of the reservoir. No. Okay.
Yeah.
I got it. Thank you.
Yeah. And another parameter is called max resolution. In our sample demo, we have 4 resolution. If you go to the highest resolution, the data could be very large. So if you have a slow internet, you might take a longer time to load data from server. So in case you don't have a good internet, you can change the setting here. So it will only render up to 30 resolution. Yeah, so if you have a low-end computer, you can still use GigaGrid, and you don't have to worry about the memory you got, the GPU you have, and other stuff like color provider and data is just the same as regular reservoir. Next, we're gonna talk about event system. That means you can have real-time interaction with the grid. For example, the first event is called after render. So this callback function is triggered after the rendering is finished, and you can use this event. For example, update cell count. After rendering, you want to see how many cells in the scene. You can update the information here. The second event is called before rendering. So before you trigger the rendering, you may want to do other stuff. Like for example, you want to have a loading screen. So you can trigger your loading screen here. During render, this callback function is triggered during the rendering. That means you can have maybe, for example, the GigaGrid is rendered 60 times per second. That means we have 60 FPS. So it's called very, very open. So we don't recommend to do like a computation here because it will consume a lot of computer resource. It's better just to update some simple stuff like a progress bar. So you can have a high idea how many data you have loaded and how many to load. The last one is render error. In case you have a internet issue, so you can show internet is slow, so you will not be able to load some data from server, or there's a server issue. Okay, so next I'm gonna show you some demo. I will start from the regular reservoir. So I'm not sure if you have seen the regular reservoir from previous version. It actually looks different from this one. So this one has a more brighter color and a lighter outline. And another feature is if you move your camera away from the grid, it's still bright. in the previous version, we have a very thick outline. So if you move your camera far away from the grid, the outline will cover the surface of the grid. So this update is much better. And of course, you can implement your own slide. For example, IJK and value. Okay. So the second demo will be GigaGrid. So we have some server information. If you implement your own server, so you will just need put some different your own parameters here. And we also have a different color map. And if we move the camera closer to a grid, you can see more cells and a higher resolution. And in this demo, I will show you how IJK works. And that's the color filter. So you can filter out the cell's color value. And also we can show how many cells we have and the capacity of total cells. Yep. So what's your question?
For the colors, is it RGB or do you support RGB?
Okay, so we use numerical color, but internally we convert it to RGB color. So that yeah, in this case we use color provider, but you can use your own color settings. Yeah. Okay, but that's what I have. So if you have more questions about 3D or reservoir, feel free to ask.